Okay, so simplifying derivatives. This is not in your book. This is my own section. So what is the first derivative? Derivative of the top, which is, I almost wrote that again, 2 times the bottom minus the top times derivative of the bottom over the denominator squared. Okay, and this is fine if this is all you had to do. Okay, but we're going to have to take the second derivative. So it's in our best interest to go ahead and simplify. And of course, if it was multiple choice, we would have to simplify enough to figure out the answer. So what does that whole numerator turn into? So just 10. So that's the first derivative. So I'm not showing all those steps. We're just distributing and combining like terms. Okay, so to find the second derivative, okay, quotient rule again, derivative of the top, 0, times the bottom, and go ahead and do this on your own. Just look up here if you need help on it. Okay, so again, if this was free response, you could just leave your answer like that. But if it's multiple choice, it's going to be simplified. And this one's not too bad because of the whole 0 times. And then instead of distributing on the top here, look what I'm going to do. Negative 10 times 2, that's going to be negative 20. And I'm going to have x plus 5 over x plus 5 to what power? If it's squared, squared to the 4th. And so you see how by not distributing the top, I can simplify even further. Okay, so this x plus 5 cancels with one of the ones in the denominator. So my final answer, I'll write over down here, is negative 20 over x plus 5 cubed. And this is how the multiple choice answer would be written. Okay, so that's just a little bit of simplifying. This one really wasn't too bad. It's just about like combining like terms and all that. Okay, let's look at problem 2. And I kind of got in this area, so I'm going to do something like this. Okay, first of all, what does this squared mean? What's being squared? The whole thing. So how do we take the derivative of cosine of 3x, the whole thing squared? Peanut M&M. Function within a function within a function. So the 2 comes down. And I kind of just wanted to throw one in again because I feel like we needed a little bit of practice on this. What would go next after this? Negative sine 3x. And the biggest mistake I see with students is they stop there. And they forget the very last step, times 3, because we got to go times the derivative of 3x. Okay, again, free response, totally fine to leave your answer just like this. No problem at all. But if it's multiple choice, they're going to clean it up a little bit. So first of all, we got a 2, we got a negative, and we got a 3. So altogether, we got a negative 6. And I'm going to write cosine 3x, sine 3x. You may see it in the multiple choice where the cosine and sine are switched. And that would be okay because I'm really just multiplying, and I can multiply in any order. So it's not always about like figuring out what their answer is. It's looking at what you have and saying which answer is equivalent. Okay, there is a trig identity that could be used here, though I really haven't seen that on recent AP tests. Do y'all remember the one where it was like sine of 2x equals 2 sine x cosine x, the double angle? You could use that here to change this, but I really haven't seen that like be required to be used. So I'm not even going to go over it, but I just kind of wanted to throw that out there. That's one reason why you've learned that. If you were to go on, if we were needing to do something else, using that identity could make the next step easier. But we can stop here. Okay, so let's look at number 3. Okay, what's happening with number 3? Product. Okay, so I got the 5x to the 4th and the cosecant x. So go ahead and do this one on your own. And if you need help, just look up at the board and see what I got going on up here. Okay, any questions about so far this problem? Okay, it seems like there's not a lot we can do here besides removing the parentheses, but a lot of times the answers are written in factored form. Okay, so we're going to practice that on this one, and then we're going to have another one in a minute where we do that. We really have 2 main groups here. Okay, and by a group, I mean terms being multiplied to each other. Okay, so I have the 20x cubed times the cosecant x, the 5x to the 4th times this thing, and they both share terms. So what I'm talking about here is greatest common factor. All right, so what is the greatest common factor of 20 and 5? 5, or just the 20 and the 5 for right now. It's a 5, right? I can divide 5 out of 20 and 5. Okay, now we dealt with the numbers. Now we have x cubed and x to the 4th. X cubed. I couldn't write x to the 4th because they both don't have it. You only write what they both have. And then when it comes to trig, what do they both have? A cosecant. Okay, so we write that. This is our GCF. And now we've got to actually factor it out. Okay, so 20 divided by 5, because remember factoring is just like dividing, is a 4. We factored out the x cubed, we factored out the cosecant. Something that, and I'm going to put a plus here, but something that might be useful here is to actually write it on here. 20 divided by 5 is 4. X cubed to x cubed. Cosecant to cosecant. By crossing off what you factored out, it may make it easier to figure out what's left. Okay, so on this next one, I factored out the 5. I factored out x cubed, and I had x to the 4th, so what's left? Just x, right? And what about the last group? What's left? Yeah, times negative cotangent x. And probably the only thing that we would see in multiple choice is that inside part would be written as 4 minus x times cotangent x. I'm not saying the answer choice would for sure be factored, but it might be, and this is just a good thing to practice. Because problems like number 4 will for sure be factored. Okay, so this is probably what the multiple choice would look like. Okay, so let's look at number 4. It's actually pretty similar to 3. There's no trig in it, but I have 2 things being multiplied. Now, because of the parentheses and power, I'm going to actually circle. So I'm multiplying here. So this still is product rule. So derivative of the first would be 2x plus 2. And you could go to the 1 power, and you could go times the derivative of the inside. Neither of these ones affect the rest of the problem, though, right? So that's the derivative of the first item times the second item. Okay, plus. So I did the first half of product rule. You do the second half. Did everybody remember the times 2 at the end? When you go times the derivative of the inside, that 2x minus 3 part, and I kind of had to move it down here so I'd have enough room. Okay, so let's look at the two groups. Okay, what would the GCF be? And first, just look at the numbers. We don't have to distribute here, which is great. We have a 2, we have a 1, we have a 3, and we have a 2. What's the GCF for the numbers? Just 2, right? Now, this is where the whole crossing off thing I think could be useful. My other classes agreed that. This is how I should have started teaching it. So I'm going to cross off that 2 and this 2. So when I go to get what's left on the inside of the parentheses, I don't even have to worry about that. Okay, what about the x plus 2's? They both have an x plus 2, so I can factor that out. And in the first group, they only had 1, so that goes away. What happens to the x plus 2 in the second group? It just goes to a single 1 instead of squared. Okay, that 1 really isn't affecting anything. What about the 2x minus 3? What's the most I can take out of both? 2, or squared. So in the first group, that 3 is going to become 1 because I took 2 of them out. And then in the second group, it cancels out. So what this does, I think, is make what you write next easier. So I have a 2x minus 3. That's the only thing left in the first group. Okay. Plus. And this plus is from this top plus here. What do we have left in the second group? X plus 2 and a 3. Okay, so are y'all okay if I write that as 3x plus 6? If you need to do that step on your own, like write it down and then again, that's fine too. But I just multiplied the 3 to both of those. And there's only one other little thing I need to do, which is combine like terms. And so the 2x and the 3x make 5x, and the negative 3 plus 6 make 3. So this right here is how your answer would be written. And if we use, like, we haven't really been using the derivatives very much, but if I needed to use this derivative, the factored form is the most convenient form to be working with. So that's another reason why sometimes we need to simplify, even if it doesn't exactly tell us to do so. Okay, so all of those were just in terms of x, distributing or deriving. Okay, how is number 5 different? It's implicit. Okay, so I'm even going to totally switch colors here to yellow. Okay, this is implicit, which means we approach it slightly different way. Okay, still deriving both sides, and I'm still deriving with respect to x, but now I have x's and y's all mixed up. Okay, so what is the derivative of negative y cubed? Negative 3y squared times dy over dx. All right, what about the next thing? X squared, y squared. Product rule. This was on your test. Something not quite, something similar to this, we'll just say. So derivative of the first thing is a 2x times the second thing plus the first thing times derivative of the second thing. The more you do this, the better you're going to get at it. You got to use product rule though. Here, there's no way out of that. Okay, what should be next? Plus, we're to the x cubed, so 3x squared is the derivative, plus the derivative of 2x to the 4th, which is 8x cubed, equals 0. Okay, so I want you to work on your own to figure out what is dy over dx. Mm-hmm. If you think you know how to simplify, go ahead and try it. So I'm not showing all my work up here. I see a few of you looking. I'm not showing all the steps. I'm just showing the answer. The steps here would be to factor, or the first step would be to keep the dy over dx terms on the left, move the other terms on the right, factor out the dy over dx, and divide. I'm not going over that today. If you're still really struggling with that, you know, come in for tutoring. I can go over it again with you. Okay, and so on the test, this is how you'd leave your answer. You'd be done, and that's perfect. Okay, there's nothing wrong with this. On a multiple choice test, the answer may look like this, and it may be altered slightly. Like, for instance, some of the terms may be written in different order. Okay, and that's okay as long as you keep your minuses where they're supposed to go. Another thing I see is that they do factor out GCF of numerator and denominator, and sometimes those even cancel. So what's something we could factor out of the top?
A negative x.
A negative x. And what I see is when the first term is negative, the negative is factored out. In this case, all three terms are negative, so I think it was a little bit more obvious. So what I'm left with is 2y squared plus 3x plus 8x squared. Okay, what can we factor out of the denominator? A y, and again, I'm going to go ahead and factor out a negative because I see that a lot happening in these problems. And so that's going to be 3y minus 2x squared. Okay, what you cannot do is just cross off these two negatives and when it was in yellow. Once you factor out the negative, then you can cancel them and they can both become plus. If only one of these was negative, you could move the negative to the front of the whole fraction. I've seen that. X and y doesn't cancel. You cannot cancel anything in the parentheses on the top with something in the parentheses on the bottom unless the whole thing was the same. Like you can't cancel off these 3's or these y's, nothing like that. If the thing in parentheses could be factored further, you would want to try that, but I'm going to tell you with the mixing of x's and y's, that's very unlikely to happen. So this is how maybe your multiple choice looks like. And again, it may look like what we started with. What you want to do is look at your answer choices and decide. So like if you just kind of turn the page, we can see number 1, by the way, is one of the hardest ones on the whole packet. So don't get discouraged. But when you're working through an implicit problem like this, look at your answer choices. That's going to help you know like how far to go in the simplifying. Okay, so at the bottom of this page, it says, now check these derivatives on the calculator. We have not done this yet. This is totally new today for the first time. Okay, so on your TI 89 flipbook, turn to the blank page. It should be page 5. And I want you to write derivatives at the top of it. And I'm going to show you how to have your calculator figure out a derivative for you. Now, what we just did is stuff we should be able to do without. So we want to use our calculator just to check our work, not do it. And then sometimes the numbers are really messy and we're going to need a calculator. And there are even some things we don't know how to take the derivative of yet that we may do on calculator parts of tests. But for today, this is mostly just going to be a check your work tool. Okay, so the first thing we need to do is, because we're going to be doing something with x, we need to clear our variables. If you have something stored for x, that's going to throw us off here. So do you guys remember how to clear your variables? So look in your, go back in your flipbook. I think it's on your first page under mode. Do you see something called clear variables? Second F1. If you don't have this, make sure you actually hit the second key. If you don't have this in your flip book, you may want to write it in there somewhere. To clear, like if you had something stored in for X, that's going to be a problem unless you want it to be that way. So we're going to clear A to Z. So you go second F1, and you can either press 1 or enter, and then it's going to say, are you sure? And you go, yep, I'm sure. So we don't want anything stored in for X before we do this. Okay, we used to go to F2 to do all the algebra. F3 is where we're going to go do our calculus. So the first thing is derivative, differentiate, D parenthesis. So select that either by pressing 1 or enter. And next we're going to write what we want to take the derivative of. So I'm going to do problem number 1. All right, so we're just going to type it in, 2x divided by, now if I'm going to divide by x plus 5, you need the parentheses. And can anyone tell me what you think we need to write next? What did we do before? Comma, x, close parentheses. Okay, just like how we did solving and all that. So what I would do is I would be doing this in your calculator, but I would also be writing it in your flip book. Write down the steps. That was F3, D. Write down what it looks like in the one line so that you know. That's the part most people forget, is like what they need to write. Make a note to remember the comma X. Now when you press enter, notice that it turns it into pretty print, okay? Which is useful because if I messed up the parentheses with that x plus 5, I could figure it out right here. All right, and we can see this is the same answer we got, 10 over x plus 5 squared. Okay, if anybody, for the first derivative we did, 10 over x plus 5 squared. And we're going to do the second derivative here in just a minute, but yeah, if you get a number over here, you have something stored in for x, and so you want to clear that. All right, let's find the second derivative. So I want you just to clear that out, and let's go through the steps again. F3, either type 1 or enter. Now you do not have to type in 10 divided by x plus 5 squared. If you hit the up key, it'll highlight, and there's like a built-in copy-paste function. If when you're highlighting something, you press enter, it'll paste it in wherever you left off. You still need to do the whole comma, x, close parentheses thing. And this is how we'll get the second derivative. And that's the same thing we got. So your calculator simplifies these for you. This is one reason why I didn't show you this earlier, because it really wouldn't have helped you until you start simplifying your answers. Okay, so this is pretty cool. This is not, you still have to know how to do these things by hand, but it's a good checking tool, and it really saves you time on calculator parts of tests. So you don't need to be doing derivatives by hand. You could just do it in the calculator. Okay, so let's try the next one, 2. So again, I'm going to clear this out. I'm going to do F3, differentiate. Now, because I wanted to square, I put in a parenthesis. I'm just going to kind of show you. I put this parenthesis in. The parenthesis that the calculator has tells me, okay, take the derivative of what's next. So I need to put in that extra parenthesis that I wrote in here. So notice I have 2 opening parentheses. Okay, then I have cosine 3x. And I'm going to close the parentheses on the 3x, and then I'm going to close them on the cosine squared, then comma x close. Notice I'm opening and closing. You know, this is where most people are going to mess up. However, you're going to figure it out if you do, because it's either going to give you an error, or you're going to look up here and you're going to go, oh, that's not what I wanted. Like if you accidentally put the squared only on the 3x, you could see it once you press enter here. And so remember how I told you the answer could have been, sine could have been before cosine? That's okay. Do you have a question? Okay. All right, for implicit differentiation, unless you have a titanium, okay, so like mine, see how it does not say titanium up there? Mine's not a titanium. Some of you might have a titanium. There is a way to do implicit differentiation. If you want me to show you, I can. It is, though, you're never going to have a calculator and get to do implicit. So it's not that big of a deal that you can't do it. Most of us can't, because only a few people have titaniums. Okay, so that's how you take derivatives. The only other thing I'd like to show you is how you can, like if in this problem, I now wanted you to find slope of a tangent line and we needed to plug in a value in for x. We know how to do that by hand. Do you guys remember how to store in the calculator? So if I wanted to store, say, pi over 4, okay, I would type in pi over 4, I would hit the store button above the on key, and then I would type x. And when I press enter, now when I type x, what it really knows is pi over 4. So I could come up here and I could select my answer, and it will calculate now the slope of the tangent line at x equals pi over 4. Again, this is all stuff you should be able to do without a calculator. It's just that's how you do your calculator. So I'm going to go ahead and clear my variables before I forget to do that. So I would suggest you do that if you've been storing. Okay, the only other thing I want to show you is in y equals. So do you guys remember how to go to y equals? Yeah, F1, or diamond F1. And I have this in here. You may or may not have this in here. It doesn't really matter. Let's just do like an F2. You can type anything you want in there. F2 zoom standard. Of course, I picked something that's totally boring. Okay, let me...
How did you get to y equals?
You go diamond F1. So I'm actually going to type in number 4 that we did. Because this will be a more interesting one. Okay, if you're going to multiply, by the way, in your calculator, you've got to go times. This calculator doesn't like implied times. And again, ooh, I did a bad thing. Do you guys see what I did? This is not a mistake I intended to make, but I'm kind of glad I did. What is my calculator thinking I put in right here? 2x times -3. That's not what I want. So what we can do is we can go over here, and I can backspace over that. And I know why it is. It's because on my computer program, it always thinks I'm doing a negative, even when I want a minus. So that's where the pretty print can really help you. Make sure that what you typed in was what you wanted to type in. So I already showed you how you could do this derivative on the home screen. So let me show you how you can look at the derivative on the graph. Okay, so let's do like an F2 standard. So F2 6. Okay, so it looks kind of weird. And what it won't do on the graph screen is actually tell me what the derivative is. But if I go to F5, I mean, like, it won't give me the expression. If you want that, you need to go to the home screen and do it the way I already showed you. But if you go to F5, do you see down here? We already did zeros and we talked about intersections before, but derivatives, I can pick dy over dx. Don't worry about the fact that there's maybe other options that are grayed out. And it can calculate the derivative at a specific point. So let's say I wanted to calculate it at x equals 2. Okay, so at x equals 2, I can tell this is pretty steep. The derivative is 104. That would be like the slope of the tangent line. This is not something you're going to use as often. I just kind of wanted to throw it in to show you that You can calculate the derivative at a point on the graph screen, or you could go in the home screen, do it this way that I showed you. You really have the two options. Write down in your flipbook whatever you think you need to remember from this. Okay.